Okay, so previously we had worked out using linest the value, the zero coupon rates. Okay, another approach here would be to use a matrix operation. So I'll just put that here underneath Control V. And say, look, the coupon payments here, the cash flows, if you like, multiplied by the discount factors, the discount factors are these guys here, right, would give us the price of the bond, which is these ones here. And if I didn't know what the D's were, right, if I just didn't know what the D's were, so these are the D's, right, the discount factors. If we didn't know those, I could actually solve, right, I could work out what they are, right, by using a matrix inversion. Now, I'm not going to labor this too much, but I probably thought I left this hanging before, and maybe just to give a little bit of clarity, how we could use a matrix operation to get the same results. If we have this set up, look, cash flows, right, multiplied by the respective discount factors, that would produce the price of the bonds. Okay, so if we don't know the discount factors and we wanted to solve for the discount factors, we could invert this relationship that we have here and say, look, if I take the inverse of the cash flows and multiply by this, they would cancel to the identity matrix. But if I multiply by the inverse of this matrix here, I must do the same on the other side. So I do. And so I end up then effectively getting a D1, D2 is equal to Dn. And if I take the inverse of the cash flow matrix and multiply by the prices, I get the discount factors, which would be these ones here. Now, how do I do that? So basically, to understand that, might consider the following, right? Go back to the prices again. So it's going to be the inverse of the cash flows, right? So we can write it this way, equal to, and go mmult, okay, open brackets, then in m inverse, and I'm going to take, if you like, this guy here and multiply. I'm going to take these inverted and multiply by the prices. So let's try that, n inverse. Okay, open brackets again, and it's the cash flow. So I'm inverting the cash flows. So inverting, if you like, inverting the cash flows here, and then we're going to do matrix operation and multiply by the prices, which are these ones here. Now I'll go negative so that they become positive. Then I close off the brackets, right? And then I hit enter. And you see what I have here is 094, 089, 084. So it's the same discount factors as what I have here. And then the last thing that we need to do in terms of working out the zero rates is to convert these discount factors into interest rates. So we need to line up our time periods. So let's copy and then paste, control, paste special, and it's transpose. Okay, so I've made the discount factor consistent with the time period, right? If we go back to the original calculation, the discount, this is the, if you like, the pricing that we had, and I need to align it to the correct time period. Okay, and then it becomes a little bit more straightforward then to say, okay, I want to estimate the pull out of this then, the zero coupon rate, it's ln, open bracket, the 094, close bracket, divided by 0.5. Okay, and notice the result I get here is consistent with what I have here. And then it's also, you can see, same as here. Okay, and we can try that again. And just adjust. Let's just drag that. That'll be fine. It'll work by dragging. And you can see the 11.65 here, same as what I had here. The 11.5 is the same as what I have here. And the 0.112989 is the same as what I have here. So these very arduous, convoluted estimations where I'm bootstrapping, and that's the technique we would use if we were manually putting together a term structure of interest rates, that can be simplified by using this matrix operation. Now you can use linest, but turned out to be just a little bit, also you had to make adopted for time. In this case, I've used the matrix operation, and the logic of the matrix operation is if we took the cash flows and multiplied by the respective time periods in a matrix operation, we would be able to get the price of each of the individual bonds, like what we have here, right? But I don't know what the discount factors are. That's something that I've got to work out. So I invert the matrix both sides. That's very complex to do if you're to do it by hand. But of course, in Excel, matrix operation is no big deal, right? To invert the matrix, we use minverse. And then we say, okay, take the inverse of the cash flows, multiply by the price, multiply by the prices. And what do we get? We get the discount rates, or the discount factor, should I say, and to convert that then to zero rates, zero coupon rates, right? It's a relatively straightforward process, zero rates. All that's required is to line that up with the correct time period, maturity, consistent with what we have here, and then take the natural logarithm by the discount factor and divide by the respective time period, and we can pull out relatively seamlessly the correct zero coupon rate, and then we avoid having to manually do this recycling, the bootstrapping of the interest rates, because here and here, these rates get put in here, and then the rate that we work out here, the 11.5, has to be put in here. So one mistake, everything goes wrong. That's not completely satisfactory in terms of just being a robust estimation. To automate it in Excel, you could use linest, which is a nice idea, or you could use a matrix operation, and this is probably the one that is, in terms of logic, is more tractable. Okay, so that then concludes that. Okay, so